All right, in lesson 22, we are going to be dividing multi-digit numbers using the standard algorithm, and we're going to be using estimation as a strategy to help us identify what our quotient is going to be. Step one, like always, is to identify our whole and our divisor. Our whole is the amount of things that we're dividing, and the divisor is the number of groups that we are dividing into. So for this problem, 590 divided by 17, we have our whole as 590 things, and we are dividing them into 17 groups, which is our divisor. One of the parts I'm adding to step one is to say your math context, to try to make meaning out of what we're doing. And one of the ways that you can do this is by answering this question. How many are in blank groups if we had blank? And what you would fill in here is your divisor would be your number of groups, and so you'd put that number in here, and then you're saying how many whole items you have total here, which would be your whole. So this would look something like, how many are in 17 groups if we had 590 things? Your quotient, which is your answer, would come in the corresponding sentence to answer the question. There would be blank, which is our quotient, in each group. If you just want to use one sentence, you can say blank divided into blank groups equals blank. And that would be our whole divided into our number of groups, or our divisor, would equal our quotient, or the amount in each group. So for this problem, it would be 590 divided into 17 groups equals blank. So we'll come back at the end and fill in our value for our quotient once we find that out. Now we get into solving using the standard algorithm, and we're going to use estimation to help us do this. So step two is you want to set up your algorithm, and when you set up your algorithm, your whole goes underneath the division sign, so 590 for us, and then 17, or how many groups, will go on the outside. So we would read this right to left, 590 divided by 17, or 590 things divided into 17 groups. Step three is we want to start our estimation. So the first step, like always, is to round our divisor. Our divisor is 17, and I can either round up to 20 or down to 10. And in this case, I'm going to round down to 20. And then the second part of this step is to find the multiples of 20. And I'm just going to continue it out here. So I have 20, 40, and I'm just adding 20 every time, or you can think of it as 20 times 1, 20 times 2, 20 times 3 is 60, 20 times 4 is 80, and 20 times 5 is 100. And I'm going to stop there. If I need to continue my multiples later on, I can do that. Now we want to move to our whole of 590. And to rename our whole, we are going to start at our highest place value in this number, which happens to be in the hundreds. So I would rename this as 500s. So now I want to ask myself, one of two questions. I want to ask myself, can this 5 hundredths be divided by the rounded divisor of 20? Or is this 5 close to a multiple of the divisor? And the closest multiple here is 20, and I'm thinking to myself, it's close, but is it close enough? Could I get a better number? If the answer to my questions is yes, then I would divide my whole, my renamed whole, by my multiple or my rounded divisor. If it's no, in this case it is no, I'm going to say I need to rename my whole to the next place value. And I had renamed to the first place value, that wasn't enough. So I'm going to rename to the next place value, which is tens. So I would have 59 tens. And here again, with my 59 tens, I'm going to ask myself these two questions. Can it be divided by the rounded divisor of 20? Or is it close to a multiple of the divisor? And I notice here that 59 is really close to a multiple of the 20. So my answer is yes. So I would do the problem 60 for my rounded whole divided by 20, my rounded divisor. And I'm remembering that this is actually 60 tens. It's not 61s, because that's going to be important when we go over to the standard algorithm. So I would ask myself, what is 60 divided by 20? How many times can 20 go into 60? And that answer is 3. But remember, it's not 3, it's 3 tens. So now I move on to my next step. Step 4 is to check estimation in the standard algorithm. To do this, we're going to take our estimation of 3 tens, and we have to line it up with the tens in our whole, which is our 9. So we add our estimation, 3, and remembering this is tens, so I'm just going to put a little t here, 3 tens, and then we multiply 3 times 17. So I'm just going to put that multiplication sign there so we remember. So we're doing 3 times 17, and then we add that down here, which is 51, and then we subtract. So it's add estimation at the top, multiply, and then subtract. And we end up with 8 tens. Just remember that this is 8 is not 8, it is actually 8 tens. Here's where I'm going to check my estimation. I have to ask myself, did I make too many where this subtraction sentence wouldn't work? Like if I had 59 minus 69, you can't take 69 away from 59 in this type of problem. So I know that I overestimated my estimation, so I would have to change this to a 2. The other question for underestimating is you look at what you have remaining and you ask, can I make another set of my divisor? Can I make another set of 17? And if you can, that means you estimated too low and you need to go up to 4. But for us, we estimated perfectly because we are left with 8. We didn't make too many sets, and we can't make another set. If the answer is yes to either of these questions, then you just adjust your quotient or your number up top as needed, whether you made too many or too few. And then you repeat the steps of multiply and subtract and see if it works out that time. Step 5 is to continue repeating steps 3 and 4 as needed. So since I'm not done, I still have this 0 in the ones place that I need to use. I've already rounded my divisor and I found the multiples. I've renamed starting at the highest, so now I need to continue renaming. So I can't make a group of 17 out of this 8, so I need to rename to my next place value. So I would bring down this 1 place value, this 0, and I would rename my 8 tens as 80 plus whatever ones I have left over. So this would be 80 ones. Then I asked myself, with this new number here, is this close to any of my multiples of my estimated divisor? And actually it is. It's right there. It's an 80. So I would write that multiplication, or I'm sorry, division sentence, 80 ones. And remember that that is a ones, divided by my rounded divisor. And I would kind of ask myself, how many 20s, or how many groups of 20 can I make out of 80? And that is 4. And remember that this is in the ones. So now we move on to step 4, is our check our estimation here. First, we place that estimation in our quotient, and it's in the ones, or over the ones place value of our whole. And then we multiply 4 times 17, and then we subtract that number from what we have remaining, which is 80. So we would subtract 68, which is 4 times 17. And then we would subtract. The 8 becomes a 7, and the 0 becomes a 10. There we go. 10 minus 8 is 2, and 7 minus 6 is 1. And remember, this is ones. And you ask yourself these two questions. Did I make too many? Is this subtraction problem not working? No. Can I make another set of 17 out of my remainder? The answer is no, so I don't need to adjust at all. And since I don't have any more numbers up here in my whole, I don't need to continue steps 3 and 4, so I can move to step 6, which is identify remainder, which is how many we have left over. So my remainder is 12. So finally, we need to check our answer, and that is quotient times divisor plus the remainder. So our quotient here is 34. We multiply that by the divisor, which is 17. And then we add our remainder of 12. So this would be the equation to check our answer. And in knowing PEMDAS, or order of operations, we know that we are going to multiply first. So 34 times 17 is equal to 578. And then we add 12. Which gives us 590. And we check that against our original whole. They are equal, so we did our math right. And we can go back to our original question. How many are in 17 groups if we had 590? The answer would be, there would be 34 in each group with 12 remaining.